component, how the Internet and information technologies unleashed by the 1996 Telecommunications Act can enable us to take full advantage of renewable energy sources and efficiency. I think of this as the energy Internet. Today, we'll explore how the Internet can revolutionize the energy sector, just as it has transformed so many other parts of our economy. We all recognize that the energy backbone infrastructure needed to integrate wind and solar resources is an issue that needs to be addressed as we move away from carbon-producing fossil fuels towards new, clean, cost-effective, renewable resources. But the backbone infrastructure needed for renewables requires more than tall towers and wide rights-of-way. To do it right, it also requires smart grid Internet protocol communications networks, open protocol smart meters, backbone sensors connected to radio spectrum, and sophisticated interactive control technologies. The U.S. electric grid has been called the most significant engineering achievement of the 20th century. It is the largest, most complex machine on the planet, with over 1 million megawatts of generating capacity and 300,000 miles of transmission lines ready for just-in-time delivery of energy to heat our homes and light our world almost wherever it is needed. However, this grid was designed for a different era. Historically, environmentally unfriendly coal, natural gas, and nuclear generators have delivered electricity to passive consumers. These customers, both large industrial users and average consumers, lack the information and incentives to change their consumption. Utilities also had limited information on grid conditions and limited ability to control and monitor demand-side resources or respond to changing grid conditions. In the era when we have gone from black rotary phones to BlackBerries, from 3 TV stations on the large appliance in your living room to YouTube on the tiny device in your pocket, we need to do better. The technology is available in 2009 to develop an energy Internet and a smart grid, and today we'll explore some of the potential technologies to accomplish that goal. Smart grid technologies can alter the way we use electricity, allow distributed generation to be sold to the grid, help utilities to integrate intermittent renewable resources, allow us to reduce carbon emissions, and allow self-healing of the grid when the system goes awry. This is not just the right thing to do. Smart grid technologies also can save consumers money. In discussing climate change legislation, we focus on the importance of putting a price on carbon to send price signals to businesses and consumers. On the electricity side, we need to ensure consumers, large and small, have good information to make wise decisions. Home-level smart grid technologies allow consumers to reduce demand and see their carbon footprint through the use of advanced meters. Smart meters, such as those placed on thermostats, washer-dryers, and refrigerators, allow consumers to respond dynamically to prices by turning down appliances and thereby reducing consumption. These end-user smart grid devices can also be adopted by utilities to control numerous electricity usages, from street lighting to industrial customers willing to reduce consumption. I am pleased that we have a panel of experts to explain the benefits and challenges facing us in the development of smart grid technologies and promoting an energy Internet. I thank you all for being here. That completes the opening statement of the Chair. We now turn to recognize the ranking member of the committee, the gentleman from Wisconsin, Mr. Sensenbrenner.
Thank you very much. Thank you. Okay. Thank you very much. Okay, reset the clock, please. Thank you very much, Mr. Chairman.
We have no clock.
Okay.
So we'll be putting pieces of paper in front of people when there's 30 seconds left to go. So.
Okay, well, thank you very much, Mr. Chairman. I look forward to hearing about the advantage of smart grid technology and the need to update our national transmission system. But technology and costs are not the only hurdles that we have to clear. Last week, the Fourth Circuit ruled that the Federal Energy Regulatory Commission, FERC for short, lacked authority to locate high-voltage transmission lines. If we can't streamline the regulatory issues for siting new transmission lines, we'll be doomed to legal battles and the same outdated grid. In his written testimony, James Hecker, counsel to the Working Group on Investment in Reliable and Economic Electric Systems, says that much of the infrastructure needed to increase our electrical transmission network will stretch over state lines. Indeed, much of the nation's wind, solar, and geothermal resources are located in the interior of the country, while many people who need that electricity live near the coasts. This will require new transmission lines, not just upgrades to the existing grid. The states and the federal government must develop a streamlined system of approving rights-of-way for new electrical transmission lines. Since many of these lines will cross several states, the federal government must lead. With regional electricity transmission networks serving numerous states, states will surely argue over the cost of these vital upgrades. Smart grid technology will encounter the same cost allocation and recovery problems that the transmission network now faces. I'm interested in hearing today about new electrical transmission technology that can make the network more efficient. But I'm also interested in hearing about what new transmission is required and how we can improve the regulatory system that oversees this expanded network. The states, the federal government, shareholders, consumers, and other stakeholders will all play a role in upgrading our energy infrastructure. These stakeholders must work together to ensure that this network can be built in a timely manner without unnecessary regulatory holdups. Let me say that earlier this week, Energy, Environment Czar, Poobah, or whatever she is in the White House, Carol Browner, talked about the need to upgrade the regulatory process in siting and building transmission lines. I think that this is one issue where Republicans and the White House can agree on. And I am looking forward to working to get together a piece of legislation that will update at least that part of the FERC law that gives FERC some power to deal with this issue. I noticed in reading the newspaper last August that a utility in Indiana wished to build a 240-mile transmission line solely within that state and not crossing any state lines. And they said in order to surmount the regulatory and litigation hurdles, they would not be able to begin construction until the year 2014. Now, obviously, that is unacceptable, and we in Congress are going to have to look at the FERC laws very closely to see what can be done to streamline the approval process for siting and construction of new transmission lines, as well as upgrading the capacity of the grid. This is going to be a challenge with many conflicting stakeholders involved, but it's something that, in my opinion, has to be done. So we can't let disputes between regulators and other stakeholders block better transmission and improved technologies that help address the energy challenges that we face. This hearing will deal with about half the issues. We better be dealing with the other half to make sure that the package is complete. Thank you.
The gentleman's time has expired. The chair recognizes the gentleman from Oregon, Mr. Blumenauer.
Thank you. Thank you. Thank you for sharing your microphone, Mr. Chairman. I find myself in substantial agreement with both statements from the ranking member and the chair, so I will I'd like to retain, forego an opening statement and add it to my my question period, if that's all right.
Excellent. The chair.
And if you my apologies to the witness. We actually, Mr. Markey's influence is being felt in my Ways and Means Committee. We're having a hearing on global warming. I'm just going to check in, tell them I'm alive, and come right back.
Excellent. Thank you. The Chair recognizes the gentleman from Washington State, Mr. Inslee.
I just want to make 3 quick points. First, we've had a start on the smart grid, which was last Tuesday when President Obama signed the Economic Recovery Plan, which made very substantial investments in smart grid technology. This is not an abstract exercise. We started last week creating green-collar jobs associated with the smart grid with the signing of the Economic Recovery Package. I may note, too, that that package included what you might think of the old-fashioned grid improvements as well. In my neck of the woods in the Northwest, it included $3.5 billion for laying wire with the Bonneville Power Administration. So the old backbone counts, too. So, number one, we've made the first step down this road. Number two, we know that this works. One of the first experiments on consumer acceptance of smart grid technology with demand management, so we can manage the amount of demand to level out peaks to reduce some of the stresses on the grid system, was in the Olympic Peninsula out in western Washington. And what the Pacific Northwest Labs found is very high consumer acceptance on some strategies to reduce the demand in peak load periods, where consumers had the ability to determine when to do their drying and when to do their washing and when to do some of their thermostat and heating of their hot water systems. Very, very high consumer acceptance to find a way to do that demand management. We know this works. And third, we do know that we have to improve our siting, planning, and financing of grid improvements in general. And I will be introducing in the next couple of weeks a bill that will make substantial improvements that will engage the offices of the federal government for siting, planning, and financing the very, very large improvements we need to the grid system, both as to timing, permitting, and a way to finance this plan. And I think the conditions are ripe for progress on this. I just note that the utility commissioners, as recently as last week, were moving forward to accept some more national effort in this regard. This is a very, very positive sign that the states are recognizing the necessity for a national movement in this regard. That's not always easy to do, and I think we should feel comforted that the states want to be partners with us in this effort. We even have the chamber on the other side of the U.S. Senate moving on these issues. So it's time for action, and thanks for this hearing, Mr. Chair.
Gentleman's time has expired. The Chair recognizes the gentlelady from West Virginia, Ms. Capito.
Thank you, Mr. Chairman. I have no opening statement. I just want to say I'm pleased this is my first hearing as a new member of this committee, and I'm very honored. I represent West Virginia, which obviously has a great interest in the direction that we're going to go as a nation. We have two high-speed, the trail and the path are grids that are going right through our state right now and are trying to decide. So I again appreciate the courtesy, and I look forward to doing this.
Great. The Chair recognizes the gentleman from New York State, Mr. Hall, for an opening statement.
Thank you, Mr. Chairman, for holding today's hearing, and thank you also to this distinguished panel of witnesses whose testimony I look forward to. I have long believed that modernizing our electric grid is critical not only to achieving energy independence, but also to coping with the looming climate crisis. So it is altogether appropriate for this committee to be holding this hearing today, as the testimony you have submitted indicates that due to the structure of the current grid, there are significant barriers to the widespread use of renewable power, something that I think many of us here, if not most of us, would acknowledge as a worthwhile policy goal. We need to have a grid that is flexible to accept power from a variety of intermittent sources, a grid that can handle power flowing in two directions, a grid that anticipates the widespread use of plug-in hybrid electric vehicles and electric cars, a grid that may be made of materials that are not 100-year-old technology, but more modern technology that does not lose so much power in transmission due to the resistance. A modern network that can carry voltage without unduly marring our landscapes and harming local ecosystems. Without those pieces in place, the investments we are making in renewable power, advanced battery technology, and electric cars will be for naught. But if we make the right decisions, we use wisely the resources provided by this Congress, then not only will we modernize our grid, but we will create good-paying jobs here at home. There's a new growth industry in smart grid technology that's just beginning to develop. Before us today are some of the first of what I hope will be many smart grid technology companies who not only find a market, but also a workforce. I've said before, the only thing more foolish than continuing to import more oil from the Saudis would be to import more solar panels from the Chinese. Well, the same could be said for smart grid technology. We cannot let the opportunity pass us by to harness the American and indeed the global market for this technology and create the industries and the jobs right here at home. Now more than ever, this is critical. Thanks to the economic recovery package signed by the President last week, the resources to begin work on the smart grid are available today. It's up to us here in this Congress and on this committee to make sure that the resources are used wisely to create jobs and solve our energy and climate crises. Again, thank you, Mr. Chairman, for holding the hearing, and I look forward to the testimony of our witnesses.
I thank the gentleman. The gentleman's time has expired. The chair now, with the permission of the other members, will recognize the gentleman from New Mexico, Mr. Lujan. He is a new member from the state of New Mexico and is an expert, actually, on these issues. Without objection, I will recognize him to make an opening statement if he would like to do so. Welcome.
Thank you, Mr. Chairman. Is this one not? Is it okay to do without voice? Yes. Thank you, Mr. Chairman and members of the committee. I'm honored to be part of this. Excuse me. Is this working?
Oh, it is working. Okay, great.
Let's fix this again, Mr. Chairman. Apologize there. I'm honored to be part of this very important discussion today as our country moves forward toward creating a green economy and reducing our dependence on foreign oil. It's imperative that we not only prepare students for the jobs of the future and assist our growing renewable energy industry, we must build transmission that includes smart grid technology that will be critical for our future. New Mexico has always been a leader in energy, and in my state, like many around the country, we have an enormous potential to grow renewable generation like solar and wind. While traveling my district last week, I had the opportunity to visit the North American Wind Research and Training Center at Mesalands Community College in Tucumcari, New Mexico. There, we also have the Northern New Mexico Solar Energy Research Park and Academy, which is growing every day. Students at the center train for the jobs of tomorrow, learning the mechanics of the wind turbines, the importance of solar generation, and applying their skills on full-size generation built right on the campus. As we train and prepare our young people for the jobs of the future, and make investments in renewable energy, we are faced with a challenge that threatens to minimize the gains we have made preparing our workforce for a clean energy economy. We all know our current electric grid design does not accommodate new renewable energy resources. We are charged with the task of building new transmission while incorporating new technologies that will improve efficiency. We must continue with fundamental research and development in areas such as energy storage and solar generation, already taking place across the country in facilities like Los Alamos National Laboratories. We must develop technologies that have the ability to store millions of watts of electrical energy that can be released back into our electric grid so we can take full advantage of the abundant renewable potential of the United States. Smart grid is a complex system, and we need to accelerate the use of computer simulation and modeling to build an ideal electric grid, a grid that will support energy efficiency, reduce our use of fossil fuels, lower consumer energy costs, and support our growing renewable energy industry as it creates jobs for the future. At Los Alamos National Laboratories, scientists are exploring the next generation of technologies needed to implement smart grid. Los Alamos has adapted the tools we use today for national security to analyze and develop solutions. As an example, resulting from renewable generation from large-scale renewable facilities and from distributed generation in homes and businesses. To get these solutions into the workplace, we need to grow new partnerships between research and development organizations like our national laboratories, our utilities, and industry aimed at accelerating the pace of discovery and commercialization. As a former public utility commissioner with the New Mexico Public Regulation Commission, I understand the importance and the urgency and the need to improve our existing infrastructure and build a new, more efficient smart grid that will allow for the deliverability of new renewable generation and improve the reliability and security of our nation's power. Deployment of smart grid technologies will create new jobs, facilitate a green economy, and change the way we generate and deliver power across America and around the world. Investments in the modernization of our electric grid is the next critical step towards a clean energy future. And I look forward to working with my fellow members to develop and implement the smart grid systems of today and tomorrow. Thank you, Mr. Chairman of the committee, for allowing me the time to be able to be here today.
Thank you, Mr. Lujan. Thank you for being here. Now we're going to turn to our witnesses, and our first witness is a very distinguished one, Mr. Tom Casey. He is the CEO of Current Group. He previously worked on telecommunications and global communications with Merrill Lynch and Skadden Arps. He was also the chief counsel of the Federal Communications Commission back in the 1970s, long ago and far away for both of us, Tom. But we welcome you, and whenever you're ready, please begin.
Thank you, Mr. Chairman. Member Sensenbrenner, Representative Sensenbrenner, members of the committee.
If you could move that microphone just in a little bit closer.
Okay. I'm here, obviously, to talk about smart grid and to try to explain the impact of what a smart grid can do for energy efficiency, for energy independence, and for emission reduction. As the chairman mentioned, we can think about a smart grid as though it was an electric internet or the internet of the electricity. I completely agree with that analogy because it is a network that must be organized, monitored, managed for the distribution of electrons as opposed to bits. But the challenges and the operational considerations that go into running the grid are very similar to the considerations that go into running the internet or telecommunications networks generally. And in fact, much of the value of the internet, as with much of the value of the smart grid, will come from not only the performance and the efficiencies it creates itself, but the fact that it enables other devices to attach to it and then to perform services on it. For example, computers on the internet, telephones on the telephone network. We don't know what the iPod or Google of the electric sector will be, but if we have a true smart grid, we can have a great deal of confidence that there will be an iPod of electricity, there will be a Google of electricity, that consumers will be taking electricity as a service. And these changes are very, very significant. If I could, and I know the committee is well aware of this, but just for the record, I would put out some statistics on the stakes of what we're talking about today. The Department of Energy has estimated that 40% of all of the greenhouse gases emitted in the country are emitted from the electric sector, from the power sector. EPRI, in turn, has forecast that if a smart grid were deployed, 25% of those emissions could be avoided, or 10% of total greenhouse gas emissions globally could be avoided. The Climate Group, a well-populated group filled with international companies, conducted a study by McKinsey, and they concluded that 2 gigatons a year of carbon dioxide or its equivalents could be avoided by the deployment of a smart grid. McKinsey said that the deployment of a smart grid is the largest single global technology contribution possible to reducing climate change. So the stakes are very high, and the smart grid is an essential element to accomplishing those benefits. So let's talk about then what a smart grid is. There's been a lot of discussion about smart grid. It's something of a generic term encompassing very large amounts of different technologies, different functions, different services. I'd like to be a little bit more precise. I believe that a smart grid is an electric grid, that is the set of wires that distributes electricity, that has had applied to it technology to do several specific things. First, to sense information on the performance and the operation of the grid. That is the electricity running on these wires? Is it at the proper voltage? Is it at the proper current? Is it in balance? All those sorts of operational things. Once that information is discovered, it must be communicated somewhere for somebody to do something with it. So there needs to be a communications channel created. And that communications channel delivers the information to some analysis capability, so a software system. The software looks at the data that it's received and decides what's going on. Is this a problem? Is it normal? Do I have to do something? Do I have to change? Do I have to turn the power on or off, up or down? And then it concludes that an action should be taken. It sends an instruction to take that action either to a person or in the sort of the next generation of smart grid to a device that's on the grid itself. And that device controls the various pieces of equipment that are on the grid to turn off or up or down or go on another path or whatever. This sounds complicated, but this is what happens every minute of every day in the telecom world. Every network is managed in this way. The internet is managed in this way. The equipment exists to do it. The software exists to do it. And we as consumers of telephony and as internet consumers, we don't even know that this is happening. But the network itself is very dynamic. Messages are moving in various ways along various paths, and the network itself is organizing that. We believe that that is what a smart grid is. I would say also that smart grid it consists of many elements, as I said. It will have thermostats in it. Eventually, appliances will have chips in them, and the appliance itself may be communicated with directly. The meter is going to be a part of the smart grid, as will the substation, as will the renewable generation, as will the solar panel on our roofs or the windmill on our chimney. All of these devices are elements of a smart grid, but they are not the smart grid itself. Just like telephones and computers are elements of telecommunications or of the internet, but they are not the internet. The internet is the network of networks, and a smart grid is the underlying network that enables all these other devices to perform to their optimal potential. I would say also smart grids are available today. Current is a small company. We're headquartered in Germantown, Maryland, just outside of Washington. But we have smart grids operating in Dallas, Texas, with Encore Electric, and in Boulder, Colorado, with Xcel Energy. These are fully equipped, operating, commercially functioning smart grid networks that work. So this is not a concept. This is not a vision necessarily. It is a vision in the sense that the rest of the country and the rest of the world, in fact, needs to adopt a smart grid technology and needs to deploy it, which is a complex and expensive undertaking that will be helped, we hope, by the stimulus package that the member just referred to. But I would say the important point here is that smart grid exists today. It's in commercial operation. And the effects that we have seen from smart grid operation, we can categorize into four general categories. System optimization. Electricity grid is a system. It starts at the generation. There's long-distance lines, which are called transmission lines. Then there's local distribution lines, which are called distribution grid. And then there's the consumer. Right? All of this network can be optimized. And by optimized, we mean that the electricity that's traveling over it is the least that is necessary to perform the functions of the users at the end of the grid. Your appliances in your home and in factories and in offices have certain requirements to have electricity of certain parameters, 120 volts. If the electricity is moving above or below 120 volts by too much or too little, it can have an effect. An optimized network will make sure that the electricity flows exactly where it's needed, or at least as close to where it's needed as possible, which will save generation. Because if we're not buying or generating energy that we're not using at the end of the day, then we're not emitting carbon equivalents, we're not spending money on generating plants, we're not siting them, we're not having any of those consequences. The second and equally important contribution of a smart grid is it enables renewables and distributed generation. Right? Renewables have certain characteristics. They are basically clean, which is why we as a nation are committed to trying to increase the deployment and the use of renewable energy. But they are also intermittent. They have variability to their production of electricity. And that poses certain challenges for the grid, because the grid right now is operated on the premise that there will be constancy of the electrons. Electrons are produced at the coal plant or the natural gas plant or the nuclear plant, and they flow in one direction till they end up in your refrigerator or in your television. And that's it. There's no complexity to that. Renewable, the sun doesn't always shine, the wind doesn't always blow, clouds can come over. They are inherently variable, they are inherently intermittent, and therefore they are inconsistent with the way that the grid is designed to be operated now. That inconsistency or that intermittency has to be dealt with, and it can be dealt with. One of the ways to deal with it is by making the grid smart, so the grid can manage the ebbs and flows of the source by managing the ebbs and flows of demand, either on the grid itself or through end user equipment. Another attribute of renewables, particularly on the distributed generation side, is If I have a solar panel on my rooftop, or if I have a windmill, or if I have some other form of distributed generation, the electric company doesn't know that I'm producing that electricity. And so several consequences occur from that. One, if they think the electricity is off on my line because a transformer has blown up, and I am in fact generating electricity from my solar panel, and they send a technician out to check, that technician thinks there's no electricity there. But there is, because I am generating. So that's obviously a safety issue. If the substation has been designed, or if all the equipment along the grid has been designed to receive certain amounts of energy coming from the generator, and the utility knows how much energy that is, but I'm adding energy to it, and the utility doesn't know that, then all their calculations about balance and about loading and about all of the technical parameters of moving the electricity are wrong. And therefore that will affect performance. These are problems that can be resolved, but they need to be resolved by having the technology that allows the utility to know what's going on the grid and to manage it more accurately.
Mr. Casey, if I could, because I think this is a great primer for all of the members, and I think they're all enjoying it a lot, but you have exceeded the 5 minutes, and if you could just make kind of more cursory reference to point 3 and 4, we'll go to the other witnesses, and then we'll come back to you during the question period, if possible.
Yes, Mr. Chair, I'm sorry about that.
Everyone is really benefiting from this overview.
I would say I made the point, just to close out, that the smart grid consists of multiple networks, some of which are in the home and some of which are on the grid. There have been studies, the climate group in this McKinsey study I referred to estimated that 85% of the carbon emission reductions from a smart grid come from the network, the part I was talking about. And 15% of the carbon emission reductions can come from in-home energy management systems. So we believe it's important when we talk about smart grid to actually have a set of priorities that allow change to be taken where it might have the most impact. Thank you, Mr. Chairman.
Thank you, Mr. Casey, very much. Our next witness, Mr. Robert Gilligan, is the Vice President and Corporate Officer for GE Energy Transmission and Distribution Business. We welcome you, sir. Whenever you're ready, please begin.
Thank you very much. Good morning, Mr. Chairman and members of the committee. Thank you for the invitation to testify on the smart grid and the tremendous opportunities it presents to our nation. Smart grid is essentially the marriage of information technology and process automation technology with our existing electrical infrastructure. It is the energy internet, as the chairman referenced, delivering real-time energy information and knowledge to grid operators and to consumers, enabling smarter energy choices. As you know, the energy challenges that we face are significant. Transmission and distribution has been underinvested in comparison with new generation in this country for more than 25 years, resulting in an aging and stressed infrastructure. By 2030, it's estimated that U.S. electrical consumption will increase by at least 30%, putting more stress on this aged infrastructure. Power outages and power disturbances in the grid are estimated to cost the U.S. economy over $100 billion a year, and the reliability of the grid is deteriorating. America spends more than $200,000 per minute importing foreign oil, putting our energy security in jeopardy. And as was referenced by Mr. Casey, climate change has become a major concern in this country and around the world, and 40% of the U.S. carbon footprint is related to power generation. Considering these factors, we must find a way to support a greener sources of energy, improved efficiency, and enable conservation. These are the three primary objectives of a smarter grid. First, to enable the integration and optimization of more renewable sources of energy and eventually plug-in hybrid electric vehicles. Second, to drive significant increases in the efficiency and reliability of our network. And third, to empower consumers to manage their energy usage and save money without compromising their lifestyles. These key benefits are clearly deliverable today and are shovel-ready to help foster energy independence and lower carbon emissions. We need to drive delivery optimization, increasing grid efficiency through network intelligence and more sophisticated controls of our transmission and distribution system. We need to drive demand optimization, empowering consumers with information to manage their usage and save up to 10% on their power bills by cutting their peak usage by 15% and their total usage by up to 8%. This has been demonstrated in studies conducted by the Department of Energy. Renewable integration, reducing our nation's dependence on foreign oil by enabling seamless integration of greener, cleaner energy technology into our networks, being able to deal with the complexity of intermittent power generating sources, and enabling plug-in hybrid electric vehicles to be a benefit to the grid as opposed to an additional burden on the grid. In addition to giving consumers power and choice, perhaps one of the most critical deliverables of the smart grid is the optimization and integration of renewable energy. GE is actively engaged with Maui Electric Power Company and the Department of Energy to solve the challenge of integrating very high penetrations of renewable energy, particularly variable sources of energy like wind and solar. A smarter grid provides utilities with levers they can pull to address changes in renewable energy production. For example, if the wind suddenly drops, utilities can quickly compensate for this variability by shedding load or finding other sources of energy that they can bring on the grid in time to maintain that support. Stimulus funding dedicated to smart grid gives us the opportunity to transform today's grid into a smarter, automated system so we can start realizing many benefits that we've talked about. This technology is available now. We believe it is in the long-term national interest to take a broad, all-encompassing view of the smart grid. To realize full benefits, funding must be focused on demonstrating solutions, not just spent on infrastructure. The inclusion of software solutions alongside infrastructure will be critical to delivering the ultimate promise of a smarter grid. A logical approach might be funding full-scale, city-scale smart grid solutions, including back-office solutions, where advanced metering infrastructure deployments have been independently funded and approved. In addition to the efficiency, environmental, and productivity benefits delivered by smarter grid, large-scale investment will also result in jobs. A study done by KEMA, an energy consulting company for the Department of Energy, the stimulus is believed to create over 150,000 new jobs within the first year and up to 250,000 jobs over the next several years. These jobs will span factories to the utilities to construction to engineering firms. By using the funding to demonstrate real benefits, we can ensure that the investment will continue after the stimulus money is spent. This will ensure that these jobs continue into the future.
If you could summarize, sir.
Yep. Another great benefit of the stimulus is that it creates the opportunity for the U.S. to lead and to create a market for these sophisticated and advanced solutions globally. We have the opportunity to be a leader in smart grid technology, just as we did for the Internet. Thank you.
Thank you, Mr. Gilligan. Our next witness is Mr. Alan Schurr. He is the Vice President of Strategy and Development for IBM Global Energy and Utilities Industry. We welcome you, sir.
Mr. Chairman and members of the committee, thank you for this opportunity to testify before you today about how a smart grid can enable a sustainable energy system with greater energy efficiency, improved reliability, and enhanced energy security. I'm Alan Schurr, and I'm Vice President of Strategy and Development, as the Chairman mentioned, and IBM is proud of its global leadership role in smart grids, as it reflects IBM's commitment to a smarter planet that is more instrumented, interconnected, and intelligent in diverse areas such as transportation systems, water supplies, healthcare, and of course energy. We believe that the application of advanced information technology, communications technology to an already digitizing equipment domain in the energy field will revolutionize the way electricity is generated, delivered, and consumed across all sectors of the economy. There are 4 key benefit areas for smart grids: more efficient use of energy by consumers, lower cost application of renewable energy supplies, operational and asset efficiency by utilities, and improved reliability and quality of electrical service. As requested by the committee, I'm going to focus on the first 2 mostly: customer energy efficiency and renewables. As I mentioned, smart grids encompass a mix of instrumentation, interconnectedness, and intelligence, and are key to ensuring we meet our environmental and energy security goals and do so cost effectively. Let me describe some examples where smart grids help achieve energy efficiency and incorporate renewables at the lowest possible cost. Energy efficiency is widely viewed as the lowest impact and most cost-effective resource. Many large enterprises like IBM have made substantial progress in reducing energy consumed per unit of output over the past 30 years. These enterprises had the scale to support detailed engineering analysis needed to identify waste in their operations and equipment, and they made investments accordingly to improve efficiency. But consumers and small businesses have not had the same opportunity. Smart grid technologies will allow improvements for all customer classes. Smart grid technologies can help track, analyze, and control energy consumption at the whole premise level and on specific appliances such as connected thermostats for a home air conditioner. Think of this as an intelligent home automation system, but utilizing internet technology and in some cases utility scale economies to dramatically reduce the cost and effectiveness. Next, renewable energy technology is a growing part of a generating portfolio that can reduce environmental impacts. Whether in a utility scale configuration or in wholly distributed installations, the integration of renewables with traditional grid operations requires special consideration, and smart grids can reduce the cost of assimilation. For example, smart grid technologies can simplify the interconnection process of distributed renewables through business process automation, communication standards, and system discovery and monitoring, just like the way the internet itself manages devices that are constantly connected and disconnected. The variability of renewable energy output is often cited as a significant objection to growing the portion of renewable energy sources, and smart grid can address this supply-demand imbalance by connecting the current and forecasted renewable output to dispatchable load. Just today, IBM announced that we are undertaking related efforts to integrate wind generation to the smart charging of plug-in vehicles so that onboard battery storage can absorb excess wind energy during controlled charge cycles. All of this is possible with the smart grid, even without new inventions. We do require new thinking, new business models, new regulatory approaches, and new applications. For us to get there, we firstly need scale deployments. They depend on both solid program management and on technology blueprints that leverage standards and interoperability for the lowest total cost. Interoperability is a necessary foundation for smart grid, and good progress is being made there. Within the electric system, interoperability means the seamless end-to-end connectivity of hardware and software from customer's appliance domain all the way up through the transmission distribution system to the power supply domain, enhancing the coordination of energy flows with real-time flows of information and analysis. The market's driving toward interoperability, and many states accurately see this issue as a means to ensure lower risk technology investments. But there are challenges that need to be addressed, including current business model challenges in the utility industry, the lack of a coherent national smart grid strategy, and the lack of smart rate making, all of which result in the fact that while there have been many pre-deployment pilots, there have been few full-scale projects.
Could you please summarize, Mr. Schurr?
Smart grids become a topic of keen interest to parties across the technology, energy, and regulatory spectrum, and its benefits to energy efficiency and renewables are well documented alongside reliability and operating efficiencies. But the hurdles really are the institutional inertia of existing regulatory models and utility businesses. Necessary technologies and solutions are available, awaiting only the orders for scale deployments to drive costs out and benefits up. Thank you very much. I look forward to your questions.
Thank you, Mr. Schurr, very much. Next witness is Mr. Charles Zimmerman. He is the Vice President of Design and Construction for the International Division of Walmart. Welcome, sir.
Thank you. Chairman Markey, Ranking Member Sensenbrenner, and distinguished members of the committee. My name is Charles Zimmerman. I am the Vice President of International Design and Construction for Walmart Stores Incorporated. In my current role, I'm responsible for coordinating the architectural and engineering system design for all of our international retail facilities. Prior to joining Walmart's International Division earlier this month, I was the U.S. Vice President of New Prototype Development and the Captain of the Sustainable Buildings Network. Here, I oversaw our company's efforts to make our buildings more energy and water efficient and lower their overall environmental impact. On behalf of Walmart and our 2.2 million associates around the world, I'd like to thank the committee for its work on this important issue and for holding this hearing today and for inviting us to appear. While I will focus primarily on our energy efficiency efforts, I will also explain the role smart grid plays in those efforts. Our company holds a unique position in the world of energy. While there are no firm statistics, it is widely understood that Walmart is one of the largest private purchasers of electricity in the world. In fact, the only entity thought to purchase more energy in the U.S. is the U.S. government. Since energy is also Walmart's second largest operating expense, it should be no surprise that we have been focused on energy efficiency and control technologies practically since the day we were founded. We have always recognized what many others have not, and that is that energy truly is a controllable expense. Because nearly 1/3 of Walmart's energy consumption is in the form of lighting, we have developed one of the most efficient lighting systems in the world. In fact, the installed lighting load in one of our newer stores is nearly 50% less than the baseline requirements established in the Energy Policy Act of 2005. This truly innovative system results in the fact that during daylight hours, our sales floor lighting is either off or significantly dimmed. This is possible thanks to a sophisticated daylight harvesting system comprised of hundreds of skylights per store that are connected to sensors and state-of-the-art control technologies. This allows our sales floor lighting system to continually modulate the amount of energy needed based on the natural light available. This system is so dynamic that it even gradually ramps the light levels up and down as clouds pass over the store. In our non-sales floor areas, such as offices, break rooms, and restrooms, lighting is controlled by occupancy sensors that turn off lights when no one is in the space. Even our freezer case lighting is now evolved to a display of advanced digital technology, as it is now comprised of LEDs or light-emitting diodes. The result is a building where most of the lighting is dynamic and only on to the degree that conditions warrant. And this is just lighting. Similar efforts are underway with HVAC and refrigeration. Recently, at the request of Walmart, Lennox International has developed a new rooftop heating and air conditioning unit that it is marketed as being, and I quote, the most efficient unit of its kind, end quote. Lennox also states that this equipment is up to 66% more efficient than U.S. Department of Energy regulations. Today, every rooftop unit purchased in the U.S. and Canada for all of our new stores and retrofits is this Lennox super high efficiency unit. This has been one of our many investments in green jobs. Of course, as efficient as all this equipment is, without proper control technology, it'll never meet expectations. That is why every Walmart store in the U.S. includes a sophisticated energy management system that allows us to monitor and control the lighting, temperature, humidity, and refrigeration in each and every one of our stores from our home office in Bentonville, Arkansas. Mr. Chairman, this is our version of a smart grid, simply awaiting arrival of the true smart grid described by Mr. Casey and others today. If an associate in Sacramento leaves the door to a walk-in Coke cooler open, we know it in Arkansas. If a store manager in Chicago overrides their daylight harvesting system, we know it in Arkansas. And if a freezer in Miami is icing up and needs to be defrosted, we know it in Arkansas. And in fact, we can correct the situation from Arkansas. In 2001, when Governor Davis asked for all businesses to curtail lighting energy use during the 2001 brownouts, we were able to do that from Bentonville, Arkansas. As efficient and
if you could summarize, please.
As proud as we are of these accomplishments and innovations, we're even more proud to share what we are learning with everyone, including our competitors. We at Walmart applaud Congress in its efforts to communicate the necessity and the benefits of energy efficiency. Thank you for your time and allowing us to speak on behalf of Walmart on this very important topic. We look forward to working with you to effectively and constructively address these issues.
Thank you, Mr. Zimmerman, very much. You sound like my mother used to sound. If you ride your bicycle outside your zone, your mother will know. I remember that lecture, but now it's coming from Walmart. Now we have another special guest today, Congressman Ron Klein from the state of Florida, who is also not a member of this committee. This is a very special morning here for us in the committee. We have so many members not on the committee who are interested in the subject, but we welcome you, sir. Whenever you are ready, please begin.
Thank you, Mr. Chairman. And thank you, all of you in this committee, for holding this and for the participants today. This is something that many of us have been interested for a very, very long time, and it isn't just about energy alternatives. It's also about conservation and so many other things, so I appreciate your leadership. Mr. Chairman, I have the opportunity today to introduce Shirley Brosmeyer. Shirley is CEO of Florida Turbine Technologies. She's a constituent In these difficult economic times, she is a great example of leadership in our business community and understanding the importance of how energy conservation can lead to great paying jobs. She employs over 185 well-paid employees at her company that work on the development, manufacturing, and testing of turbo machinery components and systems for aircraft engines, space propulsion, and industrial gas turbines. Sounds like a big, complicated thing, but actually it is an incredibly important part of our whole energy conversation that we're having. When we think of energy independence, we always think about those alternative energies, which I know Mr. Hall and many others have been leading the fight on. But it's equally important to focus on energy conservation, something Ms. Brosmeyer and her company have been working on for many years. I think you'll be very impressed with the specifics that she's going to give us this morning. And don't let her be bashful, because over the last 10 years, her company is very proud of the fact that their improvements to aircraft and industrial turbines have led to 25,000 gigawatts of green energy, which is equivalent to all of the wind turbine farms in the United States. Thank you for being here, Shirley. We appreciate your leadership in the community and nationally, and your bringing this important advancement to the committee. Thank you, Mr. Chairman.
Thank you. Welcome, Ms. Brosmeyer. Whenever you're ready, please begin. If you could turn on your microphone down there.
Is it on now?
Yes.
Okay. Thank you, Congressman Klein. Mr. Chairman and members of the committee, thank you for this opportunity to address you today. As you heard, I'm Shirley Brosmeyer, CEO of Florida Turbine Technologies, a 185-person small business in Jupiter, Florida. We develop next-generation turbine technologies for the Air Force, the Department of Energy, and aircraft and industrial engine manufacturers. We're fortunate enough to employ many of the world's foremost experts in turbine technology. While my topic is not specific to transmission today, turbine efficiency technologies should be an integral part of the discussion regarding how technology can revolutionize efficiency. In the 10 years that FTT has been in business, we've already had a huge beneficial impact on the environment, eliminating the equivalent of emissions from 8 coal-fired plants, or 30 million tons of carbon dioxide annually. Such a huge environmental impact was possible because turbines provide 97% of the electric power generated in our country. We hear lots of talk today about improving the efficiency on the consumption side of electricity, such as our dishwashers, our clothes dryers. But just as important are changes that can be made on the production side of electricity, or improving the efficiency of turbines. I'm here to tell you that turbine efficiency technology is the most cost-effective and near-term means to increase our energy independence and reduce CO2 emissions. I have a figure here on the wall, if you can see that, that shows the sources and uses of electric power in our country. I think it's probably difficult to see, but you should have it in your packet as well. On the left, you can see that fossil fuels make up a large portion of our electric power generation. But and renewable energy, which is small down there, this is a few years old, it will increase. It is increasing. But since demand is also increasing, fossil fuels will, by necessity, remain a significant part of our energy picture for many years to come. Why is high-efficiency turbines important? High efficiency is important because more power can be generated with the same existing equipment, because less fuel is needed to generate the same amount of power, and because fewer carbon dioxide emissions result because less fuel has been burned. I should start by saying that we've focused our efficiency advancements on natural gas-fired combined cycle plants, since they're the most efficient way to make power with fossil fuels. Their efficiency is close to 60%, and they produce approximately 1/3 of the carbon dioxide for the same amount of power relative to a coal plant. And also, because they're available 24/7, they make an excellent complement to most renewable sources. My company has developed an exciting new technology called spar shell blade for combined cycle power plants. This next figure shows a schematic of how such a blade would be constructed. Most turbine blades have to spray cooling air out from the inside of them to keep them from melting in their hot environment. That cooling air creates efficiency losses. Spar shell technology allows one to reduce that cooling flow by 75%. That savings in cooling air leads to a 3.5% efficiency improvement for the plant. Some other promising technologies to improve combined cycle efficiency, actually back to the other chart, are reducing the clearances between the rotating and the non-rotating parts, or reducing the cooling leakage air. And these can be combined with spar shell technology to make an upgrade kit that can be retrofit into today's turbines. This retrofitting would eliminate 60 tons of carbon dioxide every year. Okay, we can go to the next. If you could just go through all those, just keep, yeah, thanks. The final chart shows the effect of incorporating this spar shell upgrade kit into half of today's combined cycle plants, or about 60 gigawatts worth of power in the United States. With the addition of these upgrade kits, we would end up with 9 gigawatts of additional power. 3 of those would be completely fuel-free and carbon dioxide-free. With worldwide application, this additional power could reach 36 gigawatts and remove the equivalent emissions of 16 coal-fired plants. And my assumption is that we would only put these upgrade kits in about half of our existing power today. The spar shell kit would cost approximately $400 a kilowatt, which is half the price of putting in new combined cycle plants, and 1/4 the price of any other alternative.
If you could try to summarize, Ms. President,
Okay.
please.
One additional point is that because it allows higher temperatures, spar shell technology is an enabler for efficient clean coal cycles. And the Clean Coal Initiative at the Department of Energy is currently funding this. So I'd like to thank you, Mr. Chairman, and members of the committee for taking time to hear about turbine efficiency technologies. And I encourage you to include power plant efficiency improvements as part of your energy independence plan.
Thank you.
Thanks.
Thank you, Ms. Brossmeyer. Thank you for your very important contribution to this whole discussion here this morning. Our final witness is Mr. Jim Hecker. Mr. Hecker is the founder and the principal of Hecker Energy Law Policy. But most importantly, for the purposes of our hearing here today, Mr. Hecker and I go back a long, long time. Mr. Hecker was the chairman of the Federal Energy Regulatory Commission, to name just a few of his achievements. So it's good to see you again. And we welcome back, and we're sorry the table's just a little bit smaller than we had anticipated today, but we've saved you for last because of your experience. We started off with the Federal Communications Commission over here, and we end with the Federal Energy Regulatory Commission, and I think there's a good reason why we should start and end with these two subjects. So whenever you're ready, please begin.
Thank you very, very much, Mr. Chairman. I appreciate your welcome.
Move that microphone in just a little bit closer.
Okay. Good morning, Mr. Chairman, Congressman Sensenbrenner, and members of the committee. It's a pleasure to be here. I come here today as a representative of WIRES, as their outside counsel. WIRES, for your information, is a nonprofit trade group made up of transmission providers, operators, customers, technology companies, and we advocate for transmission investment. Last night, our president made it clear that we must pursue a transformational energy agenda in pursuit of alternative energy, energy independence, curbs on emissions that contribute to global warming. Today's panel is about a key piece of that agenda. As a recovering regulator, I stand in awe of the technologists at this table and what they're seeking to achieve. And I want to associate myself with their testimony with respect to the importance of digital technologies in making our electricity system cleaner, more efficient and responsive to consumer demand. I also want to acknowledge Mr. Hall's remarks about the technology that applies, perhaps not digital, but composite technologies that improve the transmission system itself, including superconductivity and such new innovations. The Wall Street Journal recently wrote about the popularity of smart roads, smart bridges, smart grids. Today I want to impress upon the committee that we need roads before we can have smart roads. We need bridges before we can have smart bridges. And we need an adequate transmission infrastructure as we apply the new technologies to help deliver reliable energy to market. The North American electricity grid is the largest machine on the planet. It is also, unfortunately, a hodgepodge of individual and regional systems, much of it aging and congested, planned by an array of entities with different agendas using different criteria, regulated by scores of agencies that use long lead times, and unable to connect to places where renewable power supplies are plentiful. The industry has nevertheless made huge advances in coordinating large transmission systems, and there are now scores of proposals on the table that, if developed, would bring clean energy supplies to market. Whether public policy favors renewables, nuclear power, advanced coal, natural gas, or all of the above, a transmission system that integrates and interconnects these new resources is essential. A stronger transmission system is not the answer to all our energy challenges, but the solutions that we and the President are talking about cannot be implemented without it. A smart grid doesn't obviate the need for transmission, but it certainly complements it. Policymakers and private companies can debate what shape this new grid should take and whether specific facilities should be built at all, but we need some basic reforms to get there. More effective and consequential planning, an understanding about who will pay for these investments, predictable cost recovery, and efficient siting procedures. We at WIRES propose to tackle some of these subjects in the Cannon House office building on Friday morning, for those of you who are interested. Mr. Chairman, I come here today in full support of what's been said, and I would like to add the interests of the transmission infrastructure to that chorus. Thank you for the invitation.
Thank you, Mr. Hecker, very much. So that completes the time for opening statements. We'll now turn to questions from the Select Committee. And the Chair will recognize himself for a round of questions. Mr. Casey, let me come to you. You were pointing out that 80% of the benefits come from one side of the equation and 20% come from the other. Can you expand upon that? Explain to us exactly what it takes let's just go to the 80%. What does it take to gain 80% of the benefits? Can you move that microphone over there, sir?
Yes, Mr. Chairman. The 80% comes, in this study, it comes from approximately half from system optimization, which is the various functions that make the electricity flow more efficiently across the grid. So that's energy efficiency or grid efficiency. Making sure that the voltage is proper, making sure the current is proper, making sure the balance between the various channels is all appropriate, making sure that when there's a transformer that is degrading, it's recognized and either fixed or electricity is routed around it in the case of an outage and so on. So that's system optimization. That's about half of that 80 to 85%. The other half of the 80 to 85% is that the renewables cannot really reach their full potential without having more intelligence in the grid to allow them to be managed and dispatched, and as we talked about before. So half of it is from the grid wires itself, and half of it is from what a smart grid will do for renewables.
And how much of that, Mr. Casey, do you think is going to be as a result of public monies having to be spent, or just a different regulatory framework in which the marketplace is responding as it did in the telecommunications field after the changes that were made that made it possible for MCI and Sprint, when you and I were working together in the 1970s, to be able now to gain better access to the network. How would you divide that question, and how much money ultimately do you think comes out of the public sector and how much out of the private sector?
I think that the money in the stimulus package will determine the answer to that question. I believe that the approximately $11 billion that's set aside in the stimulus package for smart grid or energy efficiency measures is now sitting at the DOE, and the DOE is going to have to decide how to allocate that. If they allocate it to, if they allocate it in ways that allow, as Mr. Gilligan said, solutions to be adopted at scale that can actually show the benefits of these various technologies we're talking about, then I think the market itself will take off, and you won't need any more public money. There will have to be, as several people on the panel have mentioned, there has to be regulatory changes. Because as you remember from those days, Mr. Chairman, regulated rate-based monopolists don't have a lot of incentive to be efficient.
I remember that. Yeah.
And in telecom, what happened was technology developed and new entrants came in. And then the new entrants were MCI and Sprint and Daytran and all these people. There is no competing long-distance set of carriers. There is no cable television industry that can offer VoIP channels to consumers to give them a choice. There is no wireless alternative to give them a choice. So the economic structure of the electricity industry, I think, is different. But if the regulatory regime allows them to make money by investing capital in technology that will produce efficiencies, then I think they will do it, and consumers will save money. And the society will be better off because we'll be much greener.
All right, and then expand upon that. Talk a little bit about then the ability, if we get this right, to use renewable energy, electrical generation as part of the electric vehicle revolution.
I think there will be an electric vehicle revolution, in fact, and I think it will happen faster than other people think it will happen. I think solar and wind and distributed generation at homes and in backyards, I think that's going to happen. And all of that needs a couple of things. The economics of the electric industry right now are very, very simple. They invest money, they get a return on it. They make the return by charging a number of kilowatt hours sold times pennies per kilowatt hour. So if we conserve as consumers, or if government wants a conservation policy, what that means to an electric company is they get less revenue. But they don't save a corresponding amount of costs. As an investor-owned utility, they can't possibly do that. It's not right. So the energy, the way they make money has to be altered, and that's complicated because their regulation is basically on the state level, which was another problem in telecom, and it was resolved in that sector.
My time has expired. I'll just make this point that in the 1970s, there was just this confluence where I was a graduate of Boston College, Mr. Casey was a graduate of Boston College, 3 of the FCC commissioners were graduates of Boston College, and we all agreed. It was a conspiracy. And there was no course, and by the way, there was no course at Boston College on this subject, but we all agreed that it wasn't a good idea for our mothers to have to rent a phone for $3 a month and to have everyone, every time there's a long distance call, to yell, "Grandma's on the phone, long distance, run to the phone." Why is that the case? Because one company, one utility had 1.2 million employees, AT&T, and these little companies, MCI and Sprint, wanted to get into the business. So we changed the rules. And when we changed the rules, we changed the dynamic for the deployment of this telecommunications network. Mr. Casey.
And we were all very concerned that our mothers would know that we were allowing that to continue too. So
it's exactly right. It was all driven by the same kind of guilt that Mr. Zimmerman is now inducing in people as well at Walmart, okay? And that's always the most powerful admonition that grips your brain. Let me turn now and recognize the gentleman from Oregon, Mr. Blumenauer.
Thank you, Mr. Chairman. I would like to just pick up where you left off, because for me, that's the single most important element that is woven through the testimony here today. I have no doubt that there are tremendous potential efficiencies to be wrung out of the existing system, whether it's design of turbines or just figuring out for people who don't have the benefit of scale of a Walmart, say, and don't have the focus as well, to be able to take advantage of it. And the colloquy between you, Mr. Chairman, and Mr. Casey about what we do with the regulatory system. Because ultimately we need to incent the billions of decisions that are made every day by American consumers and the businesses that serve them, and, dare I say, government itself, to be able to respond to the potential benefits. I was struck by what we've heard from GE and have been impressed with people from your organization. The IBM story, I think, is stunning in terms of your 45% reduction. Walmart, the benefits of scale and focus. One of the things that is an unsung success story. You've done it in transportation, what you've done in energy consumption. I wonder if our panelists, particularly those from these three major institutions, could follow up on the conversation, Mr. Chairman, between you and Mr. Casey, to talk about the regulatory incentives that you could envision that would help change those billions of individual decisions. Can you see a large organization like a GE or a Walmart being empowered to negotiate an energy conservation tariff to be able to get even deeper greener? Can you foresee a differential rate of return for a private utility and their customers for investments that will save energy over time? So maybe we incent that so they invest capital and time and energy, and the customers are motivated, not by altruism, not by rules and regulations, although we think that people will be motivated by what's good for the planet, and there is a role for appropriate rules and regulations. But can you talk about regulatory carrots that would make a difference to your three institutions?
I'll start if that's okay. I think that there are demonstrated models in the utility sector today that do encourage investment in efficiency. If you look at the state of California, where there is decoupling, there is encouragement for investment in efficiency. And because of that, we've seen the rate of growth in per capita electric use at about 50%. California is running about a 50% the rate of growth of the rest of the nation. So the decoupling process has been effective. In some way, we need to encourage driving efficiency and incent utilities to invest in efficiency as if they were investing in new generation. Decoupling is one mechanism. I think there's a second challenge, though. My experience around this industry is it's a conservative industry, and the regulators are very conservative about spending people's money on new technology. So we need to think about how do you encourage a given utility to be one of the first to adopt new technology.
Yeah, I'm mindful. I want to be short because I think my other colleagues want to speak, and so I won't flog this, even though I had a couple of extra minutes in my questioning. So what I would like to do is just follow up with each of you in terms of having something in writing. But Mr. Gilligan, what I am interested in, I want to be clear, and my friend Mr. Ensley has been a leader in his committee pushing decoupling. We've done this with legislation that I've been working on. But rather than thinking of it as new generation, I'm wondering if we can think of it as new lines of business. For the 4,000 power, gas, and sewer and water utilities across the country, that they can think about the partnership with you incented by appropriate regulation as actually a new line of business that could be developed. And I will yield back, Mr. Chairman, but I would be keenly interested in following up with each of our three witnesses for them to respond with the smart people they work with on how we deal with this interesting avenue that you and Mr. Casey opened up. Thank you, sir.
Thank the gentleman, and if you respond in writing, then we'll make sure each of the members receives those responses. Chair recognizes the gentleman from Washington, Mr. Inslee.
Thank you. Thank you. Mr. Heckler, I wanted to ask about the need for additional federal action and or state action on siting, planning, and financing grid improvements. I just would like you to address the urgency of that, which is a kind of a rhetorical question, but I'd like you to talk to us about why quick action is appropriate, if you believe it is. And two, how you would fashion the federal-state relationship in that regard.
Well, thank you, Congressman. I appreciate that softball, and we could talk quite a while about this. It's widely acknowledged that the existing transmission system is aging in many respects, that it doesn't reach areas where renewable energy is plentiful, that it's under a good deal of stress, and that we're looking at an increase in electricity demand of up to 30% over the next 20 years or so. Now, a lot of the technologies we've been talking about will be able to help manage that load and perhaps reduce it, make it more efficient. But the electric transmission system is an enabler not only of these technologies, but our access to renewable energy and service reliability that will enable our economy to recover. I think we're looking at a pivotal moment in the history of the grid. We're moving to new technologies where we're putting more demands on this network infrastructure, and we need to think about it holistically. The history of this industry is rooted in the early part of the last century in very discrete systems where generators were built close to load, and the only transmission was to interconnect the two over relatively short distances. Now we have an emerging, highly integrated bulk power system, and it's being asked to do things that it wasn't designed to do. So in order to expand that system, make it smarter, employ new technologies, we need a larger regional planning, either institutions or procedures. We need to take a hard look at the siting of transmission, which happens on a state-by-state basis right now. And WIRES is not advocating that states be excluded from that, but when we look at whether particular transmission facilities, especially extra high voltage facilities that are 345, 500 kV and above, that have regional impacts and perhaps even cross state lines, it makes no rational sense for the developer of those facilities to have to engage in procedure after procedure after procedure in multiple states in order to get authorization or recognition that the facility is needed. So we need to step back and take a look at this large machine and plan it on a regional basis, site it in a more efficient fashion, and allocate the costs in recognition of the fact that the high voltage transmission system has regional beneficiaries, not just local beneficiaries.
So we're going to have a draft of a bill I'd appreciate your input on here in the next few days. I hope that you'll help us take a look at that.
I'd be delighted.
Thank you. Can the panel address this issue of electrifying our transportation system? I think we're moving substantially in that direction. I saw a Battelle, I think it was Battelle research that showed we could essentially power our transportation fleet, or 85 or 90% of it, without additional generating capacity. If you could essentially use existing generating capacity at night, if you will, to charge our autos. Is that accurate, and what does the electrification of the auto industry portend to what we need to do in the grid in general?
If I could take a stab at that. We've done quite a bit of looking at the electric transportation impacts on the electric grid. EPRI's studies support what you described, in that there's substantial off-peak capacity that would support large-scale conversion of passenger vehicles to electric transportation, whether they be plug-in hybrids or battery electric vehicles. One of the challenges is that there is not enough garage capacity for everybody to park at night. Only about 1 in 5 cars parks in a residential garage that they own overnight, and so we think that there's also a challenge of public charging, which will not always be between the hours of you pick at 10 p.m., 6 a.m. when there's a lot of both generation capacity and transmission and distribution capacity. So ultimately, electric transportation is going to require smart grid intervention in order to manage charging in public situations, and particularly during the daytime, where it's not just a matter of the bulk system having enough capacity, but even lots of clustering of vehicles which might occur at a transit station or a place of employment. It will be critical that smart charging is part of, and pricing signals are part of, the ultimate scale-up of electric transportation. I mentioned today that we're working on a project where we're integrating wind with that smart charging to really create the ultimate in clean recharging.
Thank you.
Gentleman's time has expired. Here's where we are. We have 3 roll calls on the floor. We have approximately 7.5 minutes left to go, which will allow me to recognize Mr. Hall for all of his questions. We will then recess the hearing, and then reconvene in approximately 20 minutes, and then have approximately a 20-minute conclusion to the hearing. Okay, so just so everyone knows that there will be an opportunity for more questions and for Congresswoman Spear to also ask her questions. Congressman Hall.
Thank you, Mr. Chairman. I'll just ask one question of Mr. Hecker, if I may. And thank you all for your testimony. It's very, very interesting. And Mr. Schurr, your company is the largest employer in my district. Although you're not based there, I'm happy to say that IBM is a strong presence in New York's 19th district. But to Mr. Hecker, if superconductor technology is viable, is it viable? And if so, why would we consider building new transmission lines out of anything else, particularly copper line technology that's 50 to 100 years old, as some of you said? Put another way, why go to the trouble of building a new 21st century smart grid with essentially a 19th century backbone?
Thank you, Mr. Hall. I guess I would characterize superconductive research, such as that done by American Superconductor, as at the demonstration stage. This is very leading edge technology. It is there aren't many facilities to produce it, and its response, if installed in large quantities, is not entirely clear yet. They're about this big. You can bury them in the ground. It's super cooled with liquid nitrogen. It's impressive. It's got enormous potential because you can deliver massive amounts of power in a relatively short space. That at least is the concept, and I think we will find in the coming years ways to prove this technology and to begin to install it. But this is a process, and right now undergrounding any transmission and these kinds of facilities in particular is very expensive, and so I think we are looking at some long-term goals for installing some very, very beneficial technology, but I think that we are at the beginning of that process, not at the end of it.
Thank you, Mr. Chairman.
Thank you. Well, for Congresswoman Spear, we could recognize you for 3 minutes right now, if you'd like.
Thank you, Mr. Chairman. I just visited, just last week, a new company in my district called Greenbox, and they are actually creating the software to allow the homeowner, the consumer, to assess all of their electrical equipment in their homes and make determinations on whether or not they should be taking it, unplugging them or not. So my question is, it sounds like we already have the technology. We have the smart grid technology. We have the technology to be put in our homes in the form of software to really change behavior in a dramatic way. So what's preventing us from getting there?
Speaking from someone that has to pay for everything that we do, it's first cost. I mean, it's a hard struggle for consumers, for other businesses to look at all the life cycle costs and savings associated with these investments. And in today's environment, making that significant first cost is just extremely difficult for people.
But if the smart meters are indeed over 20 years pay for themselves by virtue of just the manpower you don't have coming out to read the meters, if the software is readily available and it's going to save people money from day one, literally, I mean, to me, it
right. It's
doesn't seem all
positive
that
cash
difficult.
flow from day one. And all of the initiatives that we've employed the last few years, we're typically seeing 2 to 3 year paybacks. So it's not a hard decision if you look at those costs. I can't speak for other companies, but it must just simply be the availability of that capital right now in these times.
I think it's also the incentives.
I apologize, but there's now only 2 minutes left to go to walk about a quarter of a mile, which would be a good task. But if the gentlelady would like to return, we will have more questions in approximately 20 minutes. And by the way, this is Congresswoman Spear's first hearing. She's the newest member of the Select Committee on Global Warming and Energy Independence, and she has an outstanding record on these issues in California. And we're looking forward to her participation in this incredible adventure we're on this term. So we stand in recess for approximately 20 minutes.
This is great. This is tremendous stuff you're doing.
independence and global warming. We just had a brief interlude while the members could cast votes on 3 different issues out on the House floor. We've got a brief period of time here where we can continue the question and answer period. And I'd like to ask Mr. Brosmeyer, if you could, to relate what you're saying to what Mr. Casey is saying about the network and how what you're testifying about is related to this larger revolution. Okay. If you could please turn on the microphone.
I'd be glad to do that. Thank you. Yes, the chart that I showed, and I did take the liberty to put that up there, shows the that 65% of the energy is lost in inefficiencies. This is actually in the power plant itself. There's also a value here for transmission and distribution losses on the same chart. So you can see that that's also a loss. So we're both talking about losses in efficiency, which can be helped. If those losses are reduced, then we will be able to deliver more power with our existing infrastructure. So I think we're the same in that regard. And we also are the same in that we feel there's some technology that needs to be accomplished here. In our case, we feel that technology to create retrofittable kits is a very relevant part of our energy solution, or must be. And in that case also, I believe there's some technologies, and I don't know a lot about the subject, but it sounds like an investment is really required to optimize the grid.
Okay, thank you. Back to you, Mr. Casey. You were talking in terms, I think Mr. Gilligan as well was made reference to the stimulus package and how the use of that money might demonstrate how this would work, although you made earlier reference to the fact that in Boulder, Colorado, and other locations, it's already happening. So what can we learn from what is already occurring in these communities, and what more could we learn from investments made by the stimulus package?
The 2 deployments that are in commercial operation in the United States, one in Dallas and one in the smart grid city in Boulder, are relatively small.
When you say relatively small, what do you mean?
Dallas, the network covers 125,000 homes, and Boulder, we're in the middle of building it. We're at probably 25,000 now and heading to 50,000 just within the city of Boulder itself. And those 2 networks are showing us that the conservation benefits that we talked about and the efficiency benefits that we talked about are real, that they are achievable. What the stimulus funding will do is it will overcome for other utilities the regulatory impediments to them making the same decision to start deploying in their territories.
May I ask you, what level of satisfaction does Dallas and Boulder have in their experiment thus far?
Obviously, I don't want to put words in their mouth, but the CEO of the Dallas utility wrote a letter to the chairman of the Texas Public Service Commission when we gave him our early reports saying we have just experienced the Neil Armstrong moment in electricity.
And this is in Dallas?
In Dallas.
Talking about something that happened in Houston. That's a big moment.
In Dallas.
Okay. That's what I'm
saying.
Right. That's a big moment. I mean, that's a huge
exactly.
analogy concession to be made. Yeah. And are they expanding upon that? In other words, is the success in Dallas and Boulder being built upon in Dallas?
In Dallas, while we were building the 100,000, the Texas Public Service Commission issued an order requiring that all utilities within the state of Texas enable all homes within their service territory with smart meters that had direct connect-disconnect capability. And that was going to cost some hundreds of dollars per home times some millions of homes. And so Encore,
and that would be made then part of the rate base?
Yeah, that would be made part of the rate base. In fact, they were allowed to charge a premium, a surcharge, to recover that investment. And so Encore basically stopped at the 125,000 homes and said, look, we have to go do this now, and so then we'll come back. In Boulder, they are working on it, and they have the same issue that they've committed to do 50,000 homes in Boulder, but then they intend to stop to assess whether the benefits were what they hoped they would be, and so far they have been. But then they have to go to their regulators and ask for rate recovery for the investment because they can't risk so much capital without some regulatory approval.
So as you and I remember, back in the 1970s, US Tel, a lot of these companies came out of Dallas.
Right.
The competitive telecommunications companies that were stymied. Is that a phenomenon that we're seeing in Texas right now, that this experiment in Dallas is now being embraced by the state PUC and is now something that we can expect other states to look at? In other words, what are we learning from Texas in terms of that being the laboratory? We're passing a federal stimulus for these kinds of experiments, but it seems as though Texas is moving, had already moved, notwithstanding the stimulus package.
They did, but the business structure in Texas was very different from any other business structure. In Texas, we built the network ourselves. We paid for the manufacturing of the equipment. We paid to have it installed, and we were going to offer broadband internet access to consumers plus sell smart grid services to the electric utility. So it cost them nothing to do it. And we were going to make our money back by selling broadband, and DirecTV was actually our partner in Dallas, marketing broadband internet access to consumers. So as long as they had no risk and no financial, they could take a chance. But even at that time, they stopped when the commission told them to install meters. They stopped the smart grid deployment because they had to go to install the meters. In Boulder, Xcel Energy is funding part of it, but their willingness to risk funding is limited, and so when they hit that limit, they will stop until they get regulatory approval.
And so the stimulus is needed then?
I believe until these are established, it absolutely is essential to get these other utilities to start the process where they become familiar with the benefits themselves. They can then take the data from those experiments and show it to the regulators, and then the regulators can move forward with a structure that helps.
So you think that once the individual utilities and individual PUC members become familiar with these concepts, then they embrace it and begin to implement as a state strategy as well?
I think they will when they see the benefits, yes. I think the relative benefits of meter-only installations. And I'll take two examples from the state of California. San Diego Gas and Electric received authority to invest $650 million in meters and proposed a $692 million benefit. The net value difference between the cost and the benefits was $40 million. I think SoCal Edison in California has regulatory approval to invest almost $2 billion in meters, and the value, the net value of that investment is $9 million. We have a study that Booz Allen and Kema and other utility executives have done with us, where the benefits of a smart grid are $3 billion. The net present benefits of a smart grid are $800 million. When regulators see that and see the benefits that are that significant, I think they will be willing to create structures to make it happen. But right now, it's just it's an argument, and they need to see it.
It's just an argument. Well, we do have kind of an eastern United States grid and a western United States grid and a Texas grid.
Right.
And Texas likes it that way.
Yes,
they see themselves as the lone star grid. And so we're getting some of the benefits here of this experimentation which is going on there. Mr. Gilligan, could you comment here on what Mr. Casey is saying in terms of how you view this? Are you familiar with this Dallas experiment and Boulder?
We're familiar with both. We're not participating in either one of those today. We are working with other utilities in other areas. What we see is very similar. The return on investment for meter reading alone is insufficient to justify the investment. You need to get the benefits.
Let me say that again. That's a very important sentence for everyone to hear.
Yeah. The infrastructure investment to put in place advanced meter infrastructure, the benefits from meter reading alone is insufficient to justify that investment.
What would make it sufficient, Mr. Gilligan?
You have to use that infrastructure to do demand response, so be able to send pricing signals to the consumer that allows the consumer to shed power, shed load, and get rewarded for doing that, for using the devices in off-peak power times. You also need to use that communication.
Shed load in off-peak power time. Now, can you try again to put that into English so that your mother would understand what you're working on every day?
Okay.
Can you do it for her?
Yeah.
Okay.
So how do we levelize the use of power?
You would use that
across-
word with your mother? Really?
Sure.
Come on. No, try again. Try again. You're talking to your mother. What are you doing? What are you doing today?
We're working to get a more efficient system.
Okay.
Okay?
How does that help me?
By allowing you to share in the benefits of that efficiency.
You know.
So use power when it's cheaper.
Where are you from?
From Atlanta.
How does it help me in Atlanta?
If I can use power when it's cheaper in Atlanta, I will do that. But I need to be able to I need the utility to be able to tell me when the power is expensive and when it's cheap so that I can act appropriately. So the demand response is part of that opportunity.
I know, but you're talking to your mother saying, Bobby,
she hasn't called me that in a long time.
I know she hasn't. She's watching right now on C-SPAN. They're broadcasting this, and she can have a copy of this. So what exactly are you asking for this utility? What utility is she using right now?
I have no idea.
Oh, she doesn't. She doesn't live in Atlanta.
No, she doesn't.
That's right. There aren't many Gilligans down there.
No, they aren't. They're
so
up in
where
the
are the
Northeast.
Gilligans living?
They're in Massachusetts.
There you go. I don't know why I thought that might be the case. We have the Caseys and the Gilligans and the Markeys all having a conversation here. But so explain it in Massachusetts terms to her. What community are you from in Massachusetts?
They're from outside of Boston. Cape Cod.
Cape Cod?
Yeah.
And what high school did you go to?
No, I didn't go to school there.
Oh, you did not?
No, I didn't.
Okay. So they've moved there for the weather?
Oh, yeah, it's beautiful there.
Really? Okay. So does Mr. Schurr, I'll get one more try. I'll go to Mr. Casey, then I'm going to come back to you again. Mr. Casey, can you take a whack at that question?
The benefits of what we do is that you will pay less for electricity, and you will breathe, and your children will breathe, and your grandchildren will breathe.
Right.
That's what I do when I tell my mother.
Can you tell your mother?
And she thinks I'm great.
Yeah. So, Mr. Schurr, would you like to take a whack at that question?
I would love to take a shot at that. My mother lives in Sacramento. It gets very hot in the summer, so here's how it works.
Okay.
On a hot summer day, when there are fewer resources available to generate power during those peak afternoons, if you're willing to exchange the utilities' control of your thermostat for short periods of time,
for your mother,
they will pay you money.
No, just for your mother in the course of the day.
We're not even there, Mom.
But that's a peak. You said peak. How
During
would
the
you
peak
explain to her
periods.
not using that word?
So during the hot afternoon, when power is in short supply, that is the peak.
Why is it in short supply in the middle of the afternoon?
Hot weather, everybody runs their air conditioner at the same time. Office buildings are lighting at the same time.
Now you got it. Go ahead. Now her air conditioning, everyone else's air conditioning is running. Go ahead.
So if you're willing to exchange control of your air conditioner on behalf of the good of the community.
What do you mean exchange
And
control?
let the utility control.
Who will I exchange control with?
The utility.
With the utility?
Instead
if you
of-
give the utility control over her air conditioner?
For a short period of time,
Okay.
she will receive a payment from the
payment
utility
from
to
who?
reduce her bill.
From who?
From SMUD in this case.
From who?
Sacramento Municipal Utility District, that local utility.
And they will pay her to do what?
Just give them the right to do that. It's like an emergency supply.
And then they're gonna turn down her air conditioner?
Well, in this case, turn up the thermostat for just a few degrees over maybe an hour or two.
Uh-huh.
And that peak load reduction is one of the other
That what?
benefits. Peak load reduction. You don't like that
No,
word.
go try again.
I already.
That what?
That hot afternoon load reduction.
Okay.
Is one of the benefits that advanced metering gives to the utility, in addition to meter reading reductions.
Okay. So just remember, all of you, that in order for us to pass legislation, we have to convince your mothers.
I understand.
Okay, not whoever you do your PowerPoint presentations to. You know what I'm saying? So that's the whole key to this story and how the testimony has to be. Okay. So, Mr. Zimmerman, you talk to your mother. You know, you're always thinking about your mother at Walmart, huh?
Well, actually, my mother passed away several years ago. But we do exactly already what was described here with several utility companies, all the way from giving them actual control through our system to make those adjustments, to still the old-fashioned way. They call us and say, hey, between 3:30 and 5 tomorrow, can you shed 10% of your load from your stores? And we can do that. What the smart grid allows us to do is we're making those decisions maybe a day or two ahead of time, and then we get to that time, maybe you didn't need to do it for an hour and a half. Maybe you needed to do it for 2 hours. But since we've manually programmed this, we're going to do it for that set time, for that set hour and a half, versus with the smart grid that's been described, it will only occur during the time that it really makes sense and for the duration that really makes sense. So always keep the system running at peak efficiency.
Okay. So, you know, my mother, she always said to me, Eddie, you got to learn how to work smarter, not harder. And nothing ticked her off more than these utility bills. Nothing. Or the auto insurance rate for my father, by the way, who never had an accident, but because we lived in Malden, he had a higher rate than a kid who had 3 accidents who lived in Winchester. Always used to drive her crazy. Okay, so they're all experts on these things, huh? But they don't talk about it in the terms that you are. Okay, they're utility bills. Okay, so the deal that you're going to offer to them is a deal, you know, politically as well, that we will change policies in order to benefit them, right? And that's what we have to sell here, politically. And to put it into terms that they understand as they're talking to other people in their age group about these issues, huh? And then they'll go, that's why don't we do that? I've never liked the utility, you know? I've always felt they were overcharging me. If this gives me an opportunity to, you know, save some money, then that's a great thing, okay? And that's the pitch that we have to make as public officials, right? To change the rules. And then IBM and GE and Walmart and all become beneficiaries of it, obviously, but we have to put it in those terms, huh, to win this argument. So let's do this. There is a roll call, again, that's been called on the House floor. I'm going to give everybody 1 minute to summarize for the record what you would like us all to remember from your testimony so that we can move forward. Our intent is to obviously pass legislation this year in this Congress on these issues, to add on to what was in the stimulus package, and to look at it from a regulatory perspective, from a tax perspective, and anything you can do to summarize in terms of how you view the issue and what you think needs to happen would be very helpful to us. So let's go in reverse order of the opening testimony, and we'll begin with you, Mr. Hecker.
Thank you, Mr. Chairman. My closing comment about electric transmission and the need to strengthen and upgrade the transmission grid is simply that it provides options and it provides choices. If you've got a good solid grid, you can use a preferred energy mix. You can access renewable energy. You can access the cheapest or the greenest power available. You can access emergency power. Your utility can integrate those variable resources we've been talking about, and you can serve new customers. The electric transmission grid, as I said, doesn't solve all the problems, but everything we've talked about in terms of efficiency and clean energy can't happen without transmission and a stronger transmission system.
Thank you, Mr. Hacker. Ms. Brosmeyer.
Thank you, Mr. Chairman. Yes, the incorporation of turbine efficiency technologies is so important in today's discussion on clean energy. And I'd like to really have that in everybody's mind when they think about green energy and how we should be moving to get more power as our power needs in the world increase. Spar Shell is one great example that our company has developed that would improve the amount of power available and also provide green energy, because some of the new power generated would actually require no fuel to generate. So my hope is that going forward, when people think about green energy, they say, wow, the first thing we ought to do is fix those plants that are on the ground already, some of them 30 to 50 years old, and let Florida Turbine and other companies put some new technologies in them to make them cleaner, to make them create more power, up to 15% more power, without putting too much money into infrastructure.
Thank you, Ms. Brossmeyer. Mr. Zimmerman.
Mr. Chairman, Walmart, because of our scale, represents one of the largest footprints in the world, about 750 million square feet. We have about 150 million customers walking through our doors in our U.S. stores every year. The things we've done with energy efficiency and existing control technologies, we have the data that proves the results of those efforts and the paybacks. I think part of our role is to share that. We already have relationships with NREL, Oak Ridge, DOE, and others, but we are the biggest laboratory that you could hope to find. We want to be partners in this discussion and share all that. And in closing, I just got to add, one of the things we can't lose sight of is energy efficiency. It's still the lowest hanging fruit. And as I walked into this room, I looked up at the lighting. It's T12 fluorescence. We haven't installed a T12 fluorescent lamp in a Walmart store in over a decade. We need to keep moving forward with energy efficient measures.
Did you know that the Bush administration actually missed all 35 deadlines for improving appliances and lighting from 2001 to 2007?
Well, now's our chance.
Well, now's our chance. Yeah, they missed their chance. So believe me, it's going to happen. All right, it's like that. We understand that's a classic working smarter, not harder issue. Huh? You solved problems with technology. Mr. Schurr.
Thank you for the opportunity today to testify. I think my mother will also appreciate your exchange, and I'll make sure she gets a chance to see it.
Thank you.
I think it's evident that the smart grid is needed for energy efficiency and renewables. All the testimony today came to that conclusion. Yet there is a substantial amount of inertia in the market. We don't think that inertia is from consumers or voters. We just finished 5,000 consumer survey, and they all want to be more involved. In fact, 90% of them said they want a smart meter, if you believe that. So we're sure that consumers are ready for this, and I think you're right in describing it's important that they understand what the benefits are and so forth. But this inertia is real, and I think the stimulus money will be excellent seed funding. It will get some areas started that otherwise wouldn't start, and we need to monitor that closely, and I think there could be an opportunity for additional funding to support what works. And finally, I think the DOE focus on standards would be a very helpful place to focus, where standards acceleration, already it's working, but it's working too slowly, would also be a place where we could make inroads.
And Mr. Schurr, just in terms of talking about mothers, when Bill McGowan, who was the founder of MCI, came into my office in 1977 and started talking about another phone company, I was thinking, now how is he going to do that? Will he build like 3-foot-high phone poles all across America? How can you have another phone company? How can you have lower phone bills? Because so it took me about 2 months just to internalize this shift, but you have to explain it to people in ways that they then embrace that change and try to break the connection with the old way of doing business. So we thank you for your testimony. Mr. Gilligan.
Thank you. The smart grid is about enabling high penetration of renewables, both wind and solar. It's about more efficiency, less losses and waste in the delivery system. And for my mother and consumers, it's about getting them information so they can make more informed choices about how and when they want to use their power to save money. To accelerate this and to get the most beneficial use out of the stimulus money, we're recommending that we focus on really demonstrating these benefits so that the cost-benefit equation is clear to utilities and to regulators, and that this investment continues to transform the grid well after the stimulus money is gone. We believe that the technology is ready today and the benefits are real, but it needs to be demonstrated.
Thank you, Mr. Gilligan. Mr. Casey.
Thank you, Mr. Chairman. The smart grid, as we all have acknowledged, has the potential to reduce emissions by an enormous relative amount. One expert has estimated to be the equivalent of taking 140 million cars off the road, a big impact. It's been called the single most productive application of information technology solution to climate change. 85% of the carbon emission reduction benefits come from the grid and the operation of the grid. So what is needed to make that happen? Part of it is a cost problem. We talked about that. Some of that can be solved simply by getting manufacturing volume. Some of that will be solved as the technology innovates with deployment. But we need the stimulus package that's now, the money that's now at the DOE has been given to them with somewhat flexible assignment. They have to disperse money to the programs that Mr. Gilligan talked about where we can prove this. Regulatory changes in the states need to be made so that the utilities, who are the ones who are going to deploy this equipment, actually can make money at it instead of lose money. And I think standards as well is an important element.
Great. Well, we thank each of you for your testimony today. This is a very important hearing going forward. The revolution that is now underway is something that we have to speed up. We have to make it happen faster. It will create more jobs. It will help with our environment. If we can electrify the cars that we drive, back out the oil that we import from OPEC, and make our whole system of producing goods in our society more efficient while reducing the price of electricity for people at home. So this is win, 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 win. But we have to really try to work hard now to get this done. And while my mother passed away 10 years ago, her admonitions still grip my brain, and she gave me an agenda, as each of our mothers do for what we should be doing every day. And so my intention this year is to make this revolution become something that's national and not just localized. We thank each of you for your testimony today. Thank you. This hearing is adjourned. Okay.